Yeah, sigma.
Rotated infinity.
I-80.
Okay, my attempt to be funny. I apologize. Okay.
How was it?
That's good. What kind of
Pizza pie. Okay, so today we're going to move from sequences to series. What is the difference between a sequence and a series?
They're spelling.
Permutations. And combinations.
That makes sense.
A series is essentially addition of one or more parts of a sequence.
Okay.
So if your sequence is infinite, then your series is the sum of that infinite sequence.
Okay.
So
A series is a sum of a sequence, whether it be a partial sum or an infinite sum. This is called a series, an infinite series, because it goes on forever. This would be called a partial sum, because it stops.
you don't sell it. So a series is only the infinite sum. Partial sums are just one partial sum.
Okay, so here begins our tests for convergence. Okay, we are going to be worried about, bless you,
Thank you.
whether series converge or not. Okay, today we're going to learn 3 different ways we can determine whether a series is convergent. Let's talk about what it means to converge. Approach with a definite value. Okay, so our sum, 1 plus 1/2 plus 1/4 plus 1/8. Nope. If plus 1/16, that is going to approach a value. Okay. Sometimes we can determine the value it approaches. Sometimes all we can say is, okay, it's going to converge. We're not sure. Okay. So the first thing is this. If we know what the sum is, then the limit of the sum is what it converges to. So write that down and I'll talk through it again. Woo. Okay, so basically, if we can take our sum and write it as a formula, when we find the limit of that, if it exists, then that is what our sum is going to converge to. No. No more response. Okay. So what I want you to keep in mind, though, this is not the sum of the sequence. Excuse me. This is not the limit of the sequence. It is the limit of the sum. Okay. So here is an example you will see more than just this one time.
Start.
Write it down, maybe.
I'm already pizza.
this is what we call a telescoping series, and I'll show you why it's called that. Okay, so it's not about taking the limit of the sequence. 1 over k minus 1 over k plus 1 is the sequence. It's about taking the limit of the sum. So let's go ahead and write out the sum. When we plug in 1, what's our term? Well, 1 minus 1 half, right? And then we'd add, and then we'd add 1/3 minus 1/4.
So we get 1.
All the way until
1 over infinity.
1 over n plus 1 over n plus 1. We'll see. Right? Okay, so what happens?
It's 1.
Okay, so, oh, I see. Good. Hold on. Undo. Okay, so negative 1/2 plus 1/2. Negative 1/3 plus 1/4. Negative 1/4 plus 1/4.
Yeah.
Anything else?
Negative 1 and
And 1 over n. So all of those are going to cancel, and our sum is really just 1 plus 1 over n plus 1. Okay? So I'm going to actually write this as this. The sum of the n terms. Okay? So what we can do is we can take the limits as n approaches infinity of 1 plus 1 over n plus 1. And what is that?
1.
Okay. So we're going to say that this sum that's a great question. That should be minus, shouldn't it? I got excited and it should be that. Good call. Yes, it's all wrong. Okay, so this sum converges to 1. Okay, anytime you find whether a series converges or diverges, you need to tell me why. So when this happens, I want you to tell me, because it's a telescoping series. Okay, so why is this telescoping? It's because things are canceling out and you're only left with the first and the last term of the sum. Okay, therefore we can take the limit, okay, of the sum. Okay, now the telescoping series is one of very few that we can actually write what the sum is to take the limit. Okay, it's not going to happen very often. It's something that you need to keep in mind, but not something that's going to happen very often. Okay, you actually know how to determine whether a series converges or not, and you actually learned it back in Algebra 2.
So,
Okay, so let's think about it. What kind of series, sequences in series, what kind of sequences in series did you work with in Algebra 2? Let's read out this. Arithmetic and geometric. Arithmetic. Let's think of the knowledge we have now. Are those going to converge to a number?
No.
2 plus 4 plus geometric.
Maybe.
So first of all, here is a geometric series. I will point out that some geometric series will begin at n equals 0. Some will begin at n equals 1. It's also possible to throw in like an n equals 3 in there.
Why is the infinity and n equals 0 out front?
This is so mental integration.
It's not an integral. So that's just the math type that I used, I guess.
Cool.
One still associated with the bond, one still associated with the opposite.
Okay, so do you remember the rule for when this actually adds up to a number and when it doesn't?
When it decreases.
Someone's decreasing.
So R has to be less than 1.
R has to be less than 1 or n has to be.
Well, n's an integer.
Or n is negative.
Oh, true.
Oh, never mind.
Negative 1.
Can our ratio be negative?
R can be negative, yes.
Okay, and can it converge if it R is negative?
Oh, so it has to be between
No.
negative 1 and.
So you can write it like this. Or either way, this is when our geometric series will converge. Okay? If it converges, then we know it will converge to this. Where A is the first term. So if your series begins at 0, A is the value you get when you plug in 0. If your series begins at 1, A is the value when you plug in 1. If your series begins at 15, A is the value in your series when you plug in 15 to your sequence. Okay? So first term divided by 1 minus R. Okay? So let's look at an example.
Bottom one is 5 to n minus 1. Top one is 3 to the.
Okay, so you notice that the denominator is multiples of 5. Excuse me, powers of 5.
Numerator is just double.
So that's 3 times 2 over 5 to n.
Wait. Oh, okay.
So first of all, we know that it's convergent. Okay. Converges. Why? It's a geometric series. Geometric series where R, the absolute value of R is less than 1. Okay? Can we determine what it converges to?
Yes.
We sure can. We can take the first term, and you plug it, well, our first term is 3, over 1 minus R. So we know it converges to 5.
So even if n does not start, so like, say for instance, if that started at, like 4, so
Mhm.
that your first term, then A would be 3, would A be 3 still?
So
first
term.
No. Then you would plug in 4 and find that term.
Okay.
Okay, so let's talk about something like that. Let's do a nicer one. So if I had the sum from n equals 3 to infinity of of this.
Yeah.
Then our sum would be 1/8 over 1 minus 1/2. Okay. So let's talk about, you're going to know more than just geometric series. How do you determine we have a geometric series? Okay, it's going to look like an exponential equation. You're going to have a constant raised to a power. In this case, the power is n. It could be the n minus 1 power. As long as n is the exponent to a constant, you have a geometric series. As long as there's nothing else thrown in. Now, if you throw an n, that's no longer geometric. It just has to be strictly exponential. All right. Another test. This is the last test for today. Okay. The nth term test. If a series converges, then the limit is 0. If it converges, then the limit is 0. So maybe, or maybe not, you remember geometry, which would have been your what, 7th grade year?
I took a freshman.
8.
8th grade year. Yes, good point. Your 7th grade. Okay. Freshman. Okay, if we have a statement, what other kind of statement is true?
The contrapositive.
Oh, good job. Oh, I forgot that you had seen that one. Okay, so what is the contrapositive?
If A means B, then B has to mean A.
Yeah.
No,
Well,
that's-
this
that's
is
the con-
A means B. Contrapositive is,
If not
B
B,
does
then
not
not
mean
A.
okay. So if the limit of n approaches infinity is not 0, then our series
Does not mean not.
so we call that divergence. This is our nth term test. If the limit of the sequence is not 0, then it cannot converge, therefore it diverges. So in my opinion, the very first thing you should check is whether your limit's going to be 0. Because if it's not 0, you know it doesn't even converge. Okay? We're going to get a list of like 6 or 7 different tests for convergence by the end of this, maybe more. I can't remember how many. Okay? If the limit's not 0, there's no point in moving forward. And limits, at this point in your calculus career, you can calculate quite a few limits in your head. Do you agree?
Yes.
Okay? Now, if the limit is 0, does that mean it converges? No. Okay? The only thing we can take from this is that if we have a series, if the limit of the sequence is not 0, it is not going to converge. It will diverge. Okay? So, yes.
Divide out n factorial on both the numerator and the denominator.
Can do that.
Why not?
Because factorial is 0 times no.
So what he's suggesting is that we do this. Right?
Yes.
Why can't we do that? because you can. Mathematically, that's okay, right? Now what's gonna happen here?
It's gonna go to 0.
Okay, so if we think about the limit as n approaches infinity, okay, that goes to 0. What's this?
1. Yay.
So what does this mean?
It diverges.
Okay, doesn't equal 0, so this diverges, and you have to tell me why. Nth term test. I would call it nth term test because I'm not going to know what NTT is. TMNT? I will know. Okay, next one. Okay, there are two different ways you could answer this question. Graham, what's one of them? Okay, the limit as n approaches infinity of 3 to the n is not 0, so it diverges by the nth term test. Alex, what's the other way? Stop. Stop. Let him work through it.
Oh, I got it.
Okay.
R is greater than 1.
Okay. So this diverges because it's a geometric series where the absolute value of R is greater than or equal to 1.
Could you break it apart and say that the sequence does not converge, therefore the series can't converge, or is that?
Yeah, because that isn't bounded.
The sequence isn't bounded, so the series can't.
Well, and that's basically
So R is
the nth term test, right?
No.
I mean, because you're saying the sequence isn't bounded, which means what about the limit towards infinity? It doesn't exist, right? Which isn't 0. You see what I mean there?
Well, like the limit exists for the series, or the sequence on the first one,
Uh-huh.
but it doesn't converge. And so like the limit can still exist, but it'll fail the nth term test. I think I guess I was going with R is greater than or equal to 1, so that it doesn't converge.
Mm-hmm. But what you mean, like, if a sequence is not bounded, then its sum is going to be, I mean, it's going towards infinity, right? And so if you think of that in terms of the limit is infinity, which isn't 0. I guess that's what I was trying to connect.
Yeah. Okay.
No.
I have tricked you.
No, it's not.
What's the limit of the sequence? So what does that mean?
Tells us that it does diverge.
Okay, well,
It tells us that it might not.
it tells us nothing. It tells us that the limit of the sequence is 0. Okay? Now, we do have this thing where if we know what the sum is, we can take that limit. Okay, so if I take 1 plus 1/2 plus 1/3 plus 1/4. Can you write me a rule for what the nth sum is going to be? There's not going to be a pattern. Is there?
isn't still push something about,
Maybe.
we don't know those tools yet.
We don't know that tool yet.
Cause I thought we learned something with Excel fixer now.
Maybe.
It converges to something, I'm pretty sure, doesn't it? Not with the tools we have right now.
Now the tools we have right now. What we are going to learn, our next set of tests, we're going to learn the integral test and the P-series test. And those will be more helpful to us. Okay? So we're going to take a little time out, and I want you to try some of these problems. So from page 601, we're going to take a time out. I want you to work on these.